Sima. So next topic we are studying about cyclotron. So what is the purpose of cyclotron? Sima. So it is used when particles with very high velocity they are required. Sometimes we require particles which travel with very high velocity. For example, in nuclear reactors, we require neutrons which travel with very high speed. Clear, Nama? Similarly, in doing some experiments, we need particles which travel very fast. So for getting very high speed particles, we use this cyclotron. Clear, no? So see what is the basic arrangement of cyclotron. So here there is a north pole, here there is a south pole. So what does north pole and south pole will do, ma? ఏం చేస్తాయి? ఏం చేస్తావే? They will produce magnetic field, no? So north pole, in between north pole and south pole, magnetic lines will be present. And if you draw tangent to those magnetic lines, this is the direction of B dash. So magnetic field is in the plane of the board and it is downwards. This is the direction of B dash. Clear, Nama? Where B dash is present in the plane of the board and it is downwards. This is the direction of B dash. Now, in this gap between north pole and south pole, we are placing two boxes. What is the shape of the box? Shape of the box is a D-shaped boxes. Okay, ma? And inside these boxes, it is everything hollow boxes. It means D shells, you can call them. So this is one D shell. D shell means for shape is in the form of letter D. And inside everything it is hollow. And this is another D shell. Okay, ma? What is the purpose of placing the shells is that inside the shell electric field will be zero. Okay, ma? Inside the shell electric field will be zero. What is the reason? Reason already we have studied, Nama. See here. For example, this is a charged sphere. If it is a charged sphere, electric field is only present on the surface and outside points only. Electric field on the inside is how much? Electric field on the inside will be zero, no? If it is a shell. If it is a shell, electric field inside the shell will be zero. So this is also like a shell only, no? Empty box. So inside this D shell, you can say electric field will be zero. Are you able to understand, ma? But magnetic field is not zero. Magnetic field is passing through the D shells. Are you able to understand? Which field is present, which field is not present? Inside D's, electric field is present. Magnetic field is present. Electric field is absent. This point you should be very clear, first of all. Clear, Nama? Now see. So therefore what I do is, so what is the arrangement of D's? So consider this is one D, ma. This is one D. So magnetic field is like this, entering into the boxes. And the letter D is arranged like this. Okay, ma? So D is perpendicular to magnetic field. Okay. Now what I do is, inside this D, I will pass one charge, positive charge, plus Q, for example. Okay, ma? I will give a small velocity to this positive charge and I will make it pass into this D. Now what is the direction of this charge? Charge is traveling in this direction. Okay, ma? Magnetic field is present in this direction. So it is an example of charge entering magnetic field at an angle of 90 degrees. No? This is what example? This is an example of charge entering magnetic field at an angle of 90 degrees. So when charge enters magnetic field at an angle of 90 degrees, what happens? It traces a circular path. That is what happens, no? So therefore what it does is, it slightly moves in a circular path and reaches here. Are you able to understand, ma? Now after reaching here, now it should enter into this gap, no? Now it is no longer moving in a circular path. It is, here also it is moving in a circular path because magnetic field is always present, no? So again it moves in a circular path and it will reach in between the gap between two D's. And to these two D's, I am supplying an alternating source of potential. Okay, ma? What I am connecting a alternating source of potential difference. What is meant by alternating source? First time, in first half of the circle it becomes positive. In the next half of the circle it becomes negative. The supply which we are getting also, this is also AC only, alternating form. Okay, ma? It means you can say that electric field will be varying like this. Electric field will be varying like this. Are you able to understand? Ma? So this is positive half cycle, this is negative half cycle, another positive, again negative. So this type of AC we will supply to these two Ds. Then what happens is, in this gap is present, in this gap electric field is present. Electric field is absent inside the Ds. Ds lopala electric field undadu. But in between two Ds there is some gap, no? So when charge enters into the gap, now it is under the effect of electric field. Okay, ma? So if a charge is moving in this direction, this is the direction of charge, then electric field also will be in the same direction. In that fashion, we arrange this alternating source of potential difference. Okay, ma? Charge is moving in this direction, electric field is also in the same direction. Now can you say what happens? Charge is also in the same direction, field is also in the same direction. What happens? Its velocity increases, no? Electric field will give some force. How much force it will give? It will give a force of F is equal to Q into E. Already we have studied, no? So this electric field will provide some force on this charge. Because of this F is equal to QE charge, this charge will accelerate. This charge will accelerate. Where charge will accelerate? Charge will accelerate only in the gap only. Charge will accelerate only in the gap only. Now, when velocity increases, what about the radius traced by the charge? R is equals to mv divided by qb, no? When charge enters magnetic field at an angle of 90 degrees, then it traces this much amount of radius, no? And here we know that R is directly proportional to velocity. R is directly proportional to velocity. So when velocity increases, what happens to the radius traced by the charge? Radius traced also increases. So previously it was moving in a small circle, no? Now it tries to move in a bigger circle like this. Are you able to understand? Now once again it enters into the gaps, no? Now when it enters into the gap once again, now what kind of source we are taking? Alternating source. Now positive side is completed, now negative cycle will start. It means the direction of electric field will just reverse now. Okay, ma? So now what is happening? Now charge is moving in this direction. This is the direction of plus Q, and electric field is also reversed in direction. This is the direction of electric field. Clear, no? So again what happens? Again velocity increases. If again velocity increases, so it moves and again it traces a bigger circle. Now again it enters the gap. Again electric field direction changes. So again its velocity increases. Are you able to understand, ma? So continuously velocity is increasing and radius is increasing, and finally here in this D we have a small hole, no, ma? So it finally comes out of this hole. Clear? So by the time it is coming out of this hole, what about its velocity? Its velocity is very large velocity. Okay, ma? So by this simple method we can give very high velocity or very high energy to charged particles. Okay, so question can be asked on this theory part, so be careful. Okay, so what are the points here we have to understand? Inside the D's electric field is not present. Inside the D's magnetic field is present. And inside the gap between these D's, magnetic field is also present, electric field is also present. Both are present. And in the gaps what happens? Velocity increases in the gaps only. And when velocity increases, what happens to radius? Radius also increases. So radius continuously increases. That means charge moves like this. Smaller circle, bigger circle, still bigger circle. Finally it comes out of the D. So by the time it is coming out of this vent, velocity should have become maximum. That's it. That is the condition. Clear, Nama? Now see. So two empty Ds, hollow boxes are present. Inside them electric field is 0. Magnetic field is not 0. Magnetic field is not 0. But in the gaps, 2D's electric field is present. Magnetic field is also present. Are you able to understand? And magnetic field is perpendicular to D's. Charged particle moves in a circular path inside D's. When it reaches the gap, it accelerates between the gap due to AC source. So frequency of AC source should be equal to frequency of the rotation of charge. This is one more point which you should remember. Clear, ma? So what should be the frequency of this AC source? How many times it should change per second? That depends on how many rotations charge is making per second. If it is making 10 rotations per second, its frequency also should be 10. then only it will match the frequency of the moving charge. Are you able to understand, ma? These are the points. So therefore write down. Some more points what we can write. As velocity in the gap increases, so as velocity in the gap increases, radius also increases. Radius also increases. Okay, ma? Finally, it moves out of a hole, or you can call it as a vent, in one of the D's. Okay, ma? So this is the concept of cyclotron. Now we have an equation to calculate what is the maximum energy that charged particle can possess. So maximum energy of charged particle. Okay, so we know that R is equals to mv divided by qb. Okay, ma? So R naught is nothing but maximum radius. So mv naught divided by qb. Okay, so from this I can calculate velocity. V naught is equals to qb r naught divided by m. Therefore kinetic energy is equals to half m v naught square. So half into m into q square b square r naught square divided by m square. So m and square will get cancelled. So therefore maximum kinetic energy of the particle coming out is how much? Q square b square v naught square divided by 2m. So this is the maximum kinetic energy with which particle comes out of the D. Okay, ma? Relation arthamaindi kada? Kinetic energy formula we know half mv square. And velocity from where I will get from equation of radius. R is equals to mv by q. Clear now? And where R naught and V naught, they are the maximum values. Okay? So what is R naught here? Where shall I write? So it is that velocity finally which it comes out of this hole. बहुत ज़्यादा होता है, lakhs of kilometers per second, very high velocity. Okay, so therefore V naught square and R naught square, they are V naught and R naught, they are maximum values. And when they are maximum, when they are coming out of the hole. Okay.